I'm Matt Gordon. I'm a senior consultant here at Pragmatic Works, and I wanted to give a talk today about kind of some of the hidden things about Always On. Yeah, at previous jobs, I was tasked with running a variety of Always On setups, and the marketing side of it is awesome and generally right. If it's set up right, it does keep running very well. Solves a lot of issues, that we had with past versions and maybe other high availability solutions. But it's an easy thing. It's easy to miss some kind of behind the scenes things that will really help smooth out your managing of it and will help smooth out the user experience as well. And so I wanted to do this webinar that's a deeper dive into a blog I did on this same topic. And it's my top 5 tips to keep always on, always humming, and users happy. And where this comes from, honestly, are things that I learned generally the hard way. Things that would have been fairly easy to do and set up at first, and because there just is kind of a lack of documentation of some things like this, or a lack of being able to find it easily. It was missed, and then you learn the hard way what the right way to do. So I'd like to save you folks from that. And for the 49% of you that have had a call in the last 3 months, I very much want to save you from that. And so let's go ahead and jump on into it. And before I go through this first slide, I do want to say I intend to make this as interactive as we can. So please use the question part, use the chat applet there. After every slide or two, I do intend to kind of stop it and look for questions, and I think Liz will be doing that as well. It was hard for me when I was setting all this stuff up to get this kind of training, so I want to make sure not only that I get through the information that I want to review with you guys, but hopefully you can get some questions answered either about the slides in here or something else that you're running into that's causing you issues in this same kind of forum. So anyway, on to this first slide, quorum votes. It's very interesting, when you see these, once Always On kind of came out, you were into the 2012 pre-release versions and things like that. There were a lot of handy blogs that said, here's how easy it is to set up an Always On AG. You just set your cluster up and it went through the wizard there. Here's how you set the SQL Server side of it up. Green check marks everywhere. Everything's happy and wonderful. And that's not wrong. But when you're setting it up for more than just a blog post, or more than just like a test dev environment, there's subtle things here that we really need to get right. And quorum votes is the first one. And the reason I mark this first is because I would say it's the most important. It's also the most difficult to get right. I know I've certainly worked at places like this, and I suspect some of you have as well, pardon me, where there's a real divide between the database admins and the operations side of the house. Anything having to do with clustering, storage, hardware, a lot of places, the operations folks want to keep the DBAs out of it. They want the DBAs to know as little about that as possible, and more than that, not really exert any influence over that. And so this is a very easy thing to get wrong because it's generally established outside of maybe a team that we would be on. And so just a quick review if you don't know. Cluster quorum is how the cluster monitors its health. Put simply, it's a heartbeat that it gets from every node that is a part of it. It's how it checks its resources. Generally, and we'll go over some more specific modes in the next slide, but generally if a majority of the resources of the cluster are answering back and saying, yes, I'm here and I'm able to service things, the cluster will stay up. The flip side of that is if the cluster is configured incorrectly or maybe not as well as it could be, you can set a situation in place where you lose a lot of resources or you lose enough, the cluster goes down, and the availability group, the listener goes down as well, and then you can't access anything. So SQL will have some idea of what's happened, but maybe a lot of your instance level metrics aren't going to tell you that something's happened, and that's why this is so important. So as the second point said, why is it important? Like I mentioned, cluster will be set offline if quorum is absent or not met. The key part of that there is the listener is a cluster resource, meaning if the cluster goes away, the listener does as well. And if you're not familiar with what the listener is, if you're fairly new to AlwaysOn stuff, the listener is basically the virtual network name that the SQL resources get. It is the way that applications and users should connect to your AlwaysOn AG, and it makes sure that if you're in a scenario where you've had to fail over or you've had to promote a replica to the primary for patching reasons, hardware failure, something like that, the listener will make sure that the connections are routed correctly. So what can happen is if the cluster goes down and the listener does not exist, nobody can connect to where they thought they were going. The connection will generally be totally shut down, and but all your instance level metrics are going to tell you that yes, I'm up and I'm healthy. If you go into the logs, you'll see these weird looking always on messages, but any of your database performance and uptime stuff that's not maybe always on aware is not going to know that anything happened. And so like the third sub-bullet says there, the AG will be inaccessible if quorum is lost. And that will definitely cause your phone to ring. And I have a specific situation that I was involved in at a past job where the operations side had designed the cluster, and it was a very divided house in that sense. We were not aware of the design. We knew the number of nodes. We knew the replicas. We knew the things we needed to set SQL up. Quorum votes and all that we were not a part of the process, and the votes were leaning. The primary data center had the majority of the votes, and the primary data center was taken offline for scheduled maintenance, and the cluster was lost. And that's when we learned how the vote counts were distributed. And so that's the inspiration behind this third bullet point. Is this should be a collaboration between DBAs and the ops team. And I share that story to hopefully give you guys something to share with executives, management, things like that, because sometimes you will get pushback. Well, it's a cluster thing, you database guys don't have to worry about it. And that's not true. It's very important that if your organization is adopting AlwaysOn, you need to be aware of what the setup is, and you need to understand why it is. You may not win the argument, but you need to know what's going on to make sure it's set up properly. And that's why I've put this other sub-bullet here. The DBA team, even if they don't agree with the design, which unfortunately will sometimes happen, they should understand it and know what the impacts of these design choices are. Because my experience, both personally and with colleagues, is the database admin's phone will ring first and the operations phone will ring second, and you're going to end up working with each other anyway. And it's always better to do that up front than working together under the gun because information wasn't shared and everybody wasn't sure what was going on. And so I've got another slide here, and there are much more in-depth breakdowns of this all over TechNet. I just wanted to give you guys kind of the high-level view of what this means and the general best practices. And so if you have an odd number of voting nodes, now maybe we can get a little more in depth with this towards the end, but voting nodes generally, each machine, so each server in the AG, has one vote. That can be changed by operations folks. You can take away the vote, and you can also change what's called the node weight to give servers some extra votes. But for the purposes of this and for the hour we've got, we'll keep this simple. So you can assume one vote per box. And so if you have an odd number of voting nodes, the Microsoft recommendation is basically majority wins. So where that can be tricky is what you'd like is a setup where, and part of the reason you set this up, it's often done across two or more data centers, and you want the ability basically to lose one, whether it's scheduled maintenance, natural disaster, something like that, and not affect the uptime of your overall cluster. That's not always possible. And so this first node is kind of the default that it falls into. It's the way most of these are configured. And like I said, sometimes that's okay, sometimes budget or resources dictates that, but it's important to understand the impact that may have. The next one is node and file share. And so it says it's recommended if you have an even number of voting nodes, and that's true. What my experience has been, and what I want to explain to the folks connected here, is if you're doing this across two data centers, which is typical, I have seen it done in one, and hopefully there's some questions about that, and we can get into that later. If you're set up across two, this node and file share majority, I've found it to be the most robust setup, because say you have a data center with 4 servers, and you have a backup data center with 4 more. You can add a file share witness, preferably at a third site or at a networking diverse site. And that file share witness, what it can do is it can always break the tie, basically. So if you have that setup where you've got 4 at your primary, 4 at your backup, and this file share witness, if you lose the primary either in a scheduled or unscheduled way, you're still going to have the 4 nodes of the backup plus the file share witness saying, yes, I'm still here. And so I've found that to be the most robust setup if you're trying to span data centers with this. The bottom two, kind of, I'll talk about them together. They kind of represent a hybrid with, what we can do with the new Windows clustering options and the AlwaysOn stuff, and the more traditional Windows cluster that maybe a lot of us are used to, where shared storage was a requirement. And so what this is here is it's essentially a file share witness, but it's local, and all the resources are connected to that shared disk. And so it's similar concept. You're having something either break that tie or represent a vote. Only everything has to be connected to it, and depending on the needs of your application, the setup of your data center, your version of Windows, things like that, that may be the right choice for you. And so from here, I want to move on to what I felt like was my second most important tip, and something that's easy to overlook, and that's read-only routing list. So a lot of the stuff you read about AlwaysOn is, it's really cool. You get your automatic page repair, where if there's a data page corrupted at the primary, it will call out to the replicas saying, hey, I need a good copy of this page back. I have a problem with this, and I need the copy of the page I sent you that was good back. That's all wonderful, and it is good. Where the setup, what a lot of people lose is you have the ability to steer applications and users to the replicas for read-only connections, which can be great for like web applications and things like that, where you may have a lot of screens where the user is just connecting and reading data, reading things that have happened, reviewing user records, application behavior, something like that. No writes happen maybe as a part of that, or they can be distributed. And that's the part of this that gets lost, is so, a lot of times the always-on adoption is driven by operational DBAs, server ops people, things like that. And so they see the advantages on their side of the house, and those advantages aren't clearly laid out for the application side. And so I want to give you guys this tip. So basically what a read-only routing list is, if you're not sure, is it directs read-only connections to readable secondary replicas. And it's probably beyond the scope of what we would do here. This can be kind of hard to demo. There's a lot of screens with very small type, and I didn't think it was conducive to this kind of a venue. But when you set up an always-on AG and you right-click on it and go to the properties of the AG, it will show you, the primary, each replica, what their commit mode is, and also whether it's a readable secondary or not. And that's a simple yes or no choice. If you establish replicas as readable secondaries, meaning you want these read-only connections headed there, it's a simple flip of a box from no to yes, and that's it. There's no downtime needed to make that change. You can change those roles as often as you'd like. And so that's the second point there. It's configured per availability group node. So it's per replica. And there are a variety of reasons why you would want all the replicas to be readable secondaries up to where Microsoft caps it. There's also reasons why you may not, and that just depends on the needs of your application, the security points that you want to manage, and things like that. And this third bullet point is interesting. This is not a load balancing mechanism. There is, I won't say misinformation, but when you hear this described at a very basic level, it sounds like load balancing. I've definitely sat with clients and colleagues and explained this, and they say, oh, great, so SQL Server does its own load balancing. No, not yet. And the reason I say yet, so if you're running anything SQL Server 2014 or 2012, this is not a load balancing mechanism at all. You can set up lists and set up an order, but all SQL will do is use the first available one in the list. And it won't balance them. So if you have 2 or 3 in that list, it won't balance them across those. The community technology previews of SQL Server 2016 do something where they're calling it round robin load balancing. The syntax is very similar to how you set up a read-only routing list now. The difference with 2016 is it will, in a round robin fashion, attempt to distribute the load among multiple replicas. I've set that up in test environments. It is really cool. I suspect, once 2016 is finally released, I would love to do a talk on that topic. It's really cool, and it removes the need for what a lot of places do, where they have third-party tools or third-party hardware helping SQL load balance this read-only load. There are a lot of interesting solutions out there, but that's more layers to manage, more people to be involved, things like this. I'm really excited that Microsoft has given us the opportunity with the next version to manage this ourselves. I think it's a real plus for people on the DBA side of the house. So now that you've heard this, you may say, wow, this is great. This would be real handy for my application. We're getting hammered with reads. It causes blocking, locking, all this stuff. How do I set this up? It's really fairly simple. The AG must have a listener. So it's possible to create an availability group, and you get a lot of, like I said, the automatic page repair and things like that, a lot of the kind of under the covers administrative advantages of it. You don't have to create a listener. But if you don't, you lose the ability to do this, and you lose that kind of single point where people are accessing the AG that allows you to take nodes in and out of it, up and down, all that kind of thing. Most AGs that I've worked on, most people that I've talked to, listeners, part of their default setup, but I did want to make clear that in order to use this, you do need one of those. And then, as the first point said, I wanted to reiterate that here, one or more of the replicas must be readable secondaries. And that's a very simple thing when you set it up. It's also a very simple thing to change after the fact. As I've mentioned, I have definitely been parts of setups where those rules changed, and it's a very easy change to make. And so hopefully this is something, if you guys are not aware of this feature of AlwaysOn, that it will help you, as the title of the slide says, get the workload spread out. You know, as we know, SQL Server, when handling reads and things like that, you can get into some blocking and locking issues that make our jobs definitely more exciting and a little more interesting that day. But it leads to a more stable environment if you can get those read-only connections sent to boxes kind of dedicated to that work. And it's a simple change for us, and though I didn't highlight it on the slide here, on the application or the user side, very simple change. It's a simple connection string property where you just say application intent equals read only, and then SQL will handle getting it to the right place, freeing up your primary for, you know, combined reads and writes, and hopefully smoothing out performance everywhere. That's certainly been my experience with it. Now we're on to tip 3, and this seems so simple, but I can absolutely tell you both me and others have been burned by forgetting to do this. And the smiley face cartoon there on the right was my face when I remembered. So this is a key tip, even though it seems simple when I was writing the slide. You know, it seems like something that is just obvious, but there's so many moving parts of setting up an AlwaysOn AG like this. It's not as simple as we guess. And so as we know, SQL Server, to keep things fairly simple, breaks its, let's say, user level security down into 2 different objects. So you've got your users at the database itself, you have the logins at the instance level, and you know, those are mapped to each other. So when we set up a replica, and if you're not familiar with that, I didn't want to dedicate a slide to it because it's part of an AG setup, and this is kind of tips for once you've set it up. But just to spend a minute to go over how you would usually set it up is, as you're walking through the wizard, you have a couple of different options. You can do it by hand, you can let the wizard do it for you. What both do is, once you designate a database or databases that you want to make a part of the AG, either you can do it yourself or the wizard will take a full backup, a transaction log backup, and then restore those at every replica that you've specified. And like I said, you can do it by hand, and that's probably a topic for another talk. But what that means is you're getting copies of your primary database set up on every replica. So the users that are a part of that are going with it. And that's where this can be confusing if you're not aware of this tip. So you look at it once it's set up, it's great, all the tables are there, stored procs, all my objects are there, all my users are there, they all have the right grants and all that, fantastic. And then you walk away and you say, yes, we're ready for failover testing, let's do it, everything looks healthy, I've got green check marks everywhere, all the users I'm supposed to, hit the button for failover, everything looks good to us, and the application people on the call say, we can't connect anything. We're getting all kinds of errors. It's a simple fix. I have been on that very call very early on in my AlwaysOn life, and what happens is the logins don't come over automatically because it's an instance level thing. And so, and this is This especially happens if you've added a replica kind of outside of your normal build out. You know, if you're setting up something for an application that's about to go live or a project that hasn't gone live yet. It can be very simple to script this out, or even do it by hand if it's an application that doesn't use a lot of users. Where it's easy to forget is when you get a new server, or you've decided to expand the AG or increase the number of replicas or something like that. And that's exactly what happened to me. And so what you do is you need a copy of the logins from the primary instance so everything will work well. As I mentioned, you can certainly do that by hand. If it's an application without a lot of users or something like that, and you choose to do that, that's fine. If not, Microsoft was very kind many, many years ago to give us a stored proc called SP help rev login that actually uses another one called SP underscore hexadecimal. And what that does is you can run this, and the output you get from it is all of the logins from the server that you're running it on. So in this case, you would want to run it on your primary. It will output a script for all the logins, and you can run that against all of your replicas, and then it reestablishes those links between the logins and the users, and hopefully when you do another failover test, your application folks will be very excited that they can use the logins that they're supposed to, and it's correctly mapped to the users, and everything's functioning exactly as we would hope and expect. And so I struggled with how to order these, and this one landed third just because it can be a thing where if you're not immediately aware of what happened, it sends you down all sorts of wild goose chases, and my blog mentions this as well. A lot of times the errors you're getting from the application side don't put you in the right place. They don't point you down the right path. And if you don't immediately think, oh, the logins are missing, you'll dive into all sorts of other security-related things that keep you away from what is a fairly easy fix here. And a lot of times we're working on this stuff under pressure, and anything that we can do to help all of us be under a little less pressure, in times like this definitely helps. So let's go on to the fourth point now, and then I'll take a break and see what questions we've gotten here in about the first half an hour. And so this point it's kind of twofold. It definitely relates to AlwaysOn, and that's why it's in this, and that's why I mentioned it in my blog. It's also good just to put the kind of old school DBA hat on. It's just a good thing to do, and that's it. Have a transaction log backup strategy. I'm always surprised. It's an easy thing to forget, but I'm always surprised, even with large shops, large databases, things like that. Transaction log backups can sometimes be an afterthought. You want to make sure you've got that full backup, you've got all your data. Maybe you're cutting it to a tape and taking it off site. Maybe you're moving it around, storing it somewhere else, whatever. That seems like the easiest thing to remember to do backup-wise. Transaction logs, depending on who set the database up, how it was added, things like that, can be an easy thing to leave out. And so this first part of the slide I wanted to highlight as kind of separate from the AG part of this, but it's an important thing that if you're not doing it, we should do it. So first of all, the backup strategy you'd want to pursue really depends on the database workload. And so, there could probably be a whole other talk just on bouncing around different ideas for how you want to manage that. Is it every 15 minutes for a system that's under high load? Is it every 6 hours, 12 hours, maybe even a day for a system that largely sits idle and isn't doing a lot? I'm not sure, and that's like I said, something you have to manage off, the resources you have to store them, the workload of your server, things like that. The second point here is really key, and it's key not only for a database that's participating in an always-on AG, but just any database anywhere, really, and that is regular transaction log backups are critical to regulate the size of the transaction log. And if you ever Google SQL Server transaction log growth, you'll see hundreds, even thousands of hits of people who maybe had to put the DBA hat on all of a sudden and just were introduced to a server with all these databases and say, keep it running. And the first thing that really jumps out at them is, why is the transaction log growing so much? Why doesn't it get smaller? What's going on? And this is always the first tip. And so, well, as I say, not just for something in an always-on environment, just something generally, it's critical to do these. Which leads to the third point, which is something that people in my life say, which is do something even if it's wrong. And I say that don't be so worried about finding the exact sweet spot of how often to do it that you don't have a regular log backup strategy in place. I have talked with people that were in that spot. So, well, our lead DBA says we need to do them every half an hour, and the other lead says we need to do them every hour, and they can't come to an agreement, and so we haven't instituted yet, and we have other meetings where we're waiting to decide the path. It's only going to put you at risk, because the more that log grows in an unmanaged fashion, maintenance, recovery, things like that are all going to take longer. And the fourth bullet, before we get into maybe some of the more AG-related advantages of this, is make sure you're monitoring those backups. I know this has happened to me. I suspect if we had put another poll up that said, how many of you have been genuinely surprised when a backup failed and you found out because somebody said, hey, we lost this database, where are the backups? I think if we're being honest, at some time in our lives, maybe all of us have been surprised that way. And so any sort of monitoring in place, there's a lot of great third-party tools out there. It could also be as simple as just reviewing the log history in SQL Server Agent, or setting a backup job up to email you when a backup completes or when it fails. Really no wrong answer there, just whatever works with your job and your schedule and the way you consume that information, but definitely do something, because we'd much rather get an email that the log backup failed than have somebody calling, screaming, saying, I need this database restored. You go for your log backups, you realize they've been failing for a day or two, and then you have probably some pretty unfortunate phone calls to make after that, and definitely a much harder time coming back from any sort of an incident. So now that we've kind of come back to the AG-related side of the house here, if the transaction log backups are well managed, the recovery time of your database will improve. And we won't do that here. We could take a very deep dive into some of the reasons for that. But long story short, anytime we're failing over an AG or restarting an instance or something like that, recovery time is critical. I've certainly been on calls where the management and executive types on the calls are demanding instant answers. Well, how long is it going to take? When is it going to come back? When can we write to it? This is all part of that management, and so it's important. Number two, I think most places I've been, most clients I visit, and I suspect this is the same for all of you as well, there's not an unlimited budget for storage. And so we need to use those resources effectively, especially if we're splitting up as best practices would tell us we should. If we're splitting up data and logs, TempDB, things like that, you want to be able to accurately size your log volume. You want to make sure there's room for growth there, but you also don't want to have some giant volume because you're not managing your transaction log well that then is probably taking away from other storage you could use either for other applications, for data files, or TempDB with with that application, something like that. So anything we can do to minimize the use of storage to free up budget and resources for other things is a very good thing. And this this last point here, this is the most specifically related to kind of availability group management. We've all read, whether it's a blog or TechNet, MSDN, whatever, the documentation on shrinking, whether it's shrink database or shrink file, is riddled with warnings that read something along the lines of, okay, we gave you the ability to do this. We would really rather you not do it. It's not good for it. That being said, and especially a lot of times maybe when, if you're at a larger place and a new group takes over management of databases that another group managed, or you bring some applications in-house that you've started maintaining that were written by another party, something like that, this type of management can suffer. And so you're kind of running from behind trying to get this resolved. And the time does come sometimes where we've got to run shrink file operations against logs and things like that. We hope it doesn't. In an always-on AG setup, that's much more complicated because of how the AG works. You're taking log data, you're shipping it to replicas, it's being restored there. Shrinking a file is a fairly simple process for a standalone instance. For anything within an always-on AG, it's much more complicated. And I've had to deal with it, and it's something I definitely would like to keep all of you from having to handle. It's a big pain. And it's a big pain in pursuit of something, we'd hope we don't have to do anyway. And so getting ahead of the log backups before we get into that spot can be a real time saver. It's never any fun to talk about scheduled maintenance and explain that there's going to be more downtime than you'd like to see, because we weren't doing some things that we want to do. That's not a phone call or an email that any of us want to have, and so I'd like to hopefully keep all of us from that. So what I'm going to do now, I have a handful more slides, but I do want to get into the questions here. And so, okay, so I'm just going to handle this list, and then please feel free to send in more. Like I said, I wanted to make this more interactive because I think there's a lot of questions surrounding this stuff that just there's not good venues for them to be asked. So as I go through these last few slides, definitely don't be shy about sending more in. So this first question is, do I lose in-process transactions during a failover? That's a tricky question. It depends on the nature of the application that's connecting. So the advantage of an always-on failover versus a cluster failover is with your old school Windows clustering, you're shutting the instance down and starting it up somewhere else. And so that's really very much a hard stop. With always-on AG, without getting really into the technical weeds on it, you're basically shutting the database down and bringing it up somewhere else. So it's less of a hard stop. If your application is coded to understand it's connecting to an always-on AG and it can cache, quote unquote, those in-process transactions, you'll be fine. In that few seconds where the always-on failover is actually happening, you won't be able to make a connection to it. So the answer to this basically is, it's kind of twofold. If you're in synchronous commit mode, and a transaction committed immediately before the failover, you're fine. If you're in asynchronous mode, what can happen is it will commit on the primary, but it's not waiting on the replica to commit it as well. Then it will manage that on the failover process. But if you connect during those few seconds where the failover is actually happening, so the application, from the application's perspective, the transaction is in process. If it sends that and the database, we've just started that failover in those handful of seconds, SQL Server will deny that, and so the application is going to think, well, I sent this, and then it's kind of up to the application's handling of how it does that. And hopefully that makes sense, and if it doesn't, feel free to submit more, and we should have a few minutes left over here at the end as well. So this next one, so it's basically about aliases and listeners and things like that. The DNS question is interesting. So you do, basically. Where this becomes more important and a little bit trickier, and is another area where you really need to talk to your networking and operations folks. If you have a multi-subnet AG, which honestly is probably a topic for a whole other blog and talk, there is some gymnastics that they'll have to do. And for something like that, for anything like this, I would recommend a scripted failover, which is not to say that the manual tools through the GUI aren't fine sometimes. Just, you know, for something where you're supporting a production level application, I like that script where you know it's fixed, it hasn't changed, especially if you're putting it in source control. And you know, you're always getting the same operations in the same order in about the same time frame. Just for my sanity, I like that. So if you're doing that, an important consideration there is they will have to make some DNS changes manually in that script, because the listener IP, if you're in a multi-subnet setup, can change. If you're not in a multi-subnet setup, it's fairly straightforward. The SQL should do the registration for you. I would say it's always a good practice, like I said, touch base with the networking folks when you're setting up an AG, especially once you think it's all set up, you think the listener's active, you can connect to it and all that. Have them make sure that the DNS records look like what you think you set up in terms of IP and things like that. So hopefully that helps. So we'll go through a few more, and then I'll get into the last few slides. So can read-only routing lists work in SQL 2012? Absolutely. That is, I supported a very large environment for a while. We used those quite a bit to do exactly what I said, to get, you know, basically a database design that was unwieldy enough we weren't going to be able to redesign the tables to support the kind of read load we thought we were going to run into. And so the decision was made to upgrade that environment from 2005 to 2012 and take advantage of these read-only routing lists. So I can guarantee you that those work, and they are a lifesaver, because, you know, for those of us on the administration side of the house, you'd love to be a design purist about something and tell the operations people, no, absolutely not. You cannot upgrade this as it stands. I have to redesign everything because I've realized all the stuff I did wrong and now I want to make it right. Sounds great. We can't always do that. And for something like that, where you realize maybe the tables are too wide and reads could have a performance impact on normal application behavior, read-only routing lists are a great choice. As long as you're running 2012, 2014, etc., you're fine. Next question, does containment get around the need to recreate logins? I've never specifically tested a contained database in this setup. That's an interesting question. I suspect that it would. I don't see a lot of adoption of that out there, and so my tip was kind of just for more of what I've seen. It's an easy thing to forget. It's something I really want to go test now, because I suspect it would, but I don't want to say 100% yes it will until I've actually tested it and done it. But I think that would be a good option if it's something you're permitted to do. And as Robert says, so I see we have a bit of a thread here. And so yeah, that is a perfectly good way to do that. Like I said, I haven't always seen environments where, for whatever reason, contained databases are a permitted design choice. You see a lot more kind of the older school way to do it. And so I want to make sure I got that help out to those folks. Let me handle just a couple more, and then I'll get back into the slides. So we've got one here. It says, how do I create notifications when the DB fails to another node? That answer's got a few layers to it. There, you can always trigger off things in the log. You know, if all you have available to you is SQL Server itself, you can create notifications based off severity levels and things like that, and you can do them kind of the old school way. If you're fortunate enough to have really any of the third-party tools that I've used, even if they're not maybe as progressive in their always-on awareness, you can still create some alerts for things that they're showing, and it's usually a database starting and stopping or something like that. A lot of the third-party tools, you know, AlwaysOn is not technically new, and so a lot of them have kind of caught up, and they have very handy notifications where you just get an email when an AlwaysOn event happens. So if you have one of those tools, great. If not, you can definitely use agent jobs and look for the AlwaysOn events in the logs and create notifications that way. And that's actually a great idea. I'd love to blog about that because that is very handy, and I know because I've been to clients and things like that. Not everybody's fortunate enough to have one of the cool monitoring tools. A lot of us are doing it the old school way by hand, and so I'd like to try to help those folks out. So let me get back to my slides. Hopefully I can get through a few more of these. Like I said, we've got about 13 minutes left, and so I can run all the way up to noon if you guys would like. But let me get back through the tips, and we'll go from there. So, okay, let's get that out of there. Okay, so my last two slides have to do with not so much keeping AlwaysOn up. So this last tip and then the slide that follows this is more making sure the performance is what you want, and this is very specific to if your replicas are in asynchronous mode. And so what I've seen, it's a very common thing, and index maintenance is very good, and there are a lot of good talks. There were good things at past Summit about it, kind of ways to do that, solutions to do that. So I'm not going to get into all those, but I will say this. Hopefully, I hope we're all doing that. Like the first bullet says, if you're not doing this, you should be. There are lots of very smart people that kind of delve into the bits and bytes of how you want to do this, rebuild versus reorganize, things like that. Seek that out and do what best fits your workload and time. But so for the purposes of the rest of this slide, I'll assume we're all doing something. And so, as I say, that strategy depends on your workload. For some applications, they're not used at night. They're a business hours only thing. If you need to and the data skew dictates that you do, you can rebuild them all night. You're not affecting anything great. For something that's 24/7 and you don't want to hit the resources at all, and even an online index rebuild is not great, your maintenance strategy is going to be far different. But the one thing I do want to highlight is reorganized operations generate more log traffic than rebuilds. And the reason that's important for us is that it is transaction log traffic that we are, sending across the wire to these other servers. And so we want to be aware that we're generating it, and not only that, but that we're handling it effectively. And so what I've seen happen, and it's the reason for this slide, is if you have a database where you have kind of a concentrated maintenance period, the conventional wisdom would be to jam all of your index maintenance in there. Anything you want to reorganize, anything you want to rebuild, you do it all at once and keep it out of the way of the normal business operations of the system. The thing to be aware of is that has an impact on the performance of your AlwaysOn AG in terms of how the replicas perform and how far behind they are. And the final slide is actually a script that I found handy that hopefully you guys will find handy as well to monitor that and kind of get a good console level view without having to buy a tool. And that kind of gets us into the second bullet here. The effect is if you're rebuilding a large index, you can generate a lot of log traffic, and it's kind of silent. It's not anything unless you're sitting there watching it, watching the file, or you have, alerts set up to handle this. It's not going to be easy to see. And as I mentioned, that log data must get to the replica, it must be restored, and the logs need to be hardened there. So if you're sending a lot, they're going to have a hard time keeping up. And the personal story that I have about this is I worked on a system where it supported retail operations for grocery stores mainly. And so there was kind of a sweet spot for that kind of heavy lifting maintenance between about 3 a.m. and 6 a.m. But the problem was, as the tables and indexes grew, as the software ran longer and longer, the index rebuilds began to spill very close to the edges of that window and sometimes over it. There were a few large tables that would trigger the rebuild threshold every so often, and when they did, we would wake up in the morning to alerts that the replicas were 15 minutes behind or something like that. And it's not because they were performing poorly, there's so much traffic. They were restoring it, hardening the logs as fast as they could. They just couldn't keep up. And any sort of network or storage utilization chart looked like my picture to the right there. Everything was totally jammed up. And so what the solution to that is to stagger it. Have a good understanding of the database that you're supporting and understand, why you're rebuilding and reorganizing things when you are, and kind of what the thought process is behind that, and spread it out. That's very important. And so that gets into these do's and don'ts, and we've got just a few minutes here for me to get to my final slide, which I hope is a script that will really help you guys stay on top of this. So do ensure that all large indexes are not being rebuilt at nearly the same time. It's an easy trap to fall into. Like I said, you've got that window, you want to do it. If you begin to see issues where the replicas fall behind, which means you wouldn't be able to fail over and have all the data that you want to have, spread these out. Understand where the large tables are, how often they rebuild, things like that, and get them spread out where it's easier for the replica to manage that traffic. Second point is do closely monitor the lag between the primaries and the replicas, especially when your index maintenance strategy, you're either establishing it new for the first time or you've made a change. Keep a close eye on it. Set up monitors, alerts, things like that. Make sure you understand the impacts. As I said, and I have lived this, do not reorganize every index each day at the same time lest your network look like this picture. And so this final slide, and I'll just run through it briefly and hopefully handle a couple more questions before I hand this back over to Liz, is go ahead and download this slide deck. I've put this in here as text. It's very small type, so we could all go over this, but you should be able to cut and paste it out and use this right now. And so what this does is it uses basically 4 DMVs that are in SQL Server, keeping an eye on cluster states, replica states, things like that. And it's giving you a readout, and I found this especially when you're managing a failover, scheduled, unscheduled, whatever. If you run this against your AG, you get a really handy, more detailed view of what's going on, how far behind things are down to the millisecond. Are you in synchronous mode, asynchronous mode? Is the primary sending things like it's supposed to? Is the replica receiving them and hardening them like it's supposed to? It goes well beyond what the AlwaysOn dashboard does, and that's part of the GUI. It's handy, but it's kind of a general health check. And I have seen circumstances where the AlwaysOn dashboard said everything was good, everything was healthy, green check marks all the way. This query exposed issues that were happening that the AlwaysOn dashboard had not caught up to yet. So this is really handy if you're in an active failover process. And so with that, I'll handle a couple more questions, just here probably another minute or two, and then hand it back over to Liz, because I know we don't want to run over our hour here, because I'm sure we're all busy and have lots and lots of stuff to do. So, okay, let's see what else we got here late. Okay, so I will take this one from Tim. It says, AlwaysOn with the remote location set to synchronous. We had performance problems despite available bandwidth with some AlwaysOn specific waits. Async fixed this, but were we missing something in the setup of sync updates? Probably not. So I will say this, a lot of the solutions that I've supported over the years, you definitely degrade performance setting it to synchronous mode if your data centers are geographically dispersed. As I referenced earlier, a lot of times we're dealing with environments where the budget is limited and sacrifices are made. This will take all the bandwidth you offer it, but when we're looking at maybe a transaction that takes milliseconds on the primary end, then it's got to run the wire, get to a replica, and commit there. Even the most robust networks, going across hundreds of miles, for a lot of your smaller to mid-sized shops, the latency is just too high. I will say within SQL Server, there's very little that we can do to make that network use more efficient. Having said that, and this will be my last point, there are, depending on your network setup, and I'm out of my depth to get into any great detail about this. Talk to your network administrators about this. There are places I've worked, clients I've worked with. There are some network tools and appliances that can make this more efficient. And I don't have time and really can't get into all the different manufacturers and tools, but I have found it very fruitful over the years to talk to the network admin, say, here's what's going on, here's the speed we're seeing. They usually have a tool or two in their toolbox that can help you out. And so with that, we're sitting here at 11:58 my time. Liz, I will hand it back over to you.
Okay, great. For those of you that are interested in downloading Matt's PowerPoint, if you go to the handouts section in the GoToWebinar panel, you'll be able to download it from there. So I'll leave it up for just a few moments before or a few moments after we end the webinars to make sure everybody has time to download that. As always, the session is recorded and it will be posted by the end of the week on our website, and you all will receive a follow-up email tomorrow with the direct link. If you have any questions, Matt's contact information is up on the slide right now, and you can also reach out to me, Liz. It's the email that comes with all your GoToWebinar information. Thanks everybody for joining us today, and we hope to hear from you again soon. Thanks, Matt.
Thank you, Liz.